Hey, I want to explain to you why it's so hard to push a beach ball into the water. See here, I got a balloon. I don't have a beach ball, so I use balloon instead. And also I got a very small ball here. So see, if I try to push this balloon, it's very hard to push it fully into the water. But with this small ball, it's very hard. I can even use 2 fingers to push it fully into the water. But not for this balloon. Why? That is, I believe many of you guys think about the buoyancy force. That's correct, buoyancy force. The water will resist the object from pushing it into it because of the buoyancy force. But before I go into the details explaining about the buoyancy force, I need you guys to understand what is the density before the buoyancy force. And also I will tell you guys about tell you guys a story about the density. So the density is a physical description of an object that is given a unit volume, a space, and you need to measure how weight does this object has. Weight, that is a mass. So the object, the density is given by this equation, the mass, the m over the volume, v. And the story is about the Archimedes. So the Archimedes is a scientist of the king Hiero of the Syracuse. Yeah, there is one day the king Hiero of the Syracuse want to make a gold crown, and he gives some gold material to his goldsmiths. And after the crown has completed, the king Hiero worries about whether the goldsmith steal some gold away, so he fools the king Hiero, and the crown is actually made of silver or something else. So he called his scientist Archimedes and tell him, Archimedes, I have a task for you. You have to examine whether my crown is made of pure gold or something or not, and without making any damage to the crown. So that's a very hard question to Archimedes, because how? Without any damage. So he kept thinking for days, and there's one day when Archimedes was taking a bath, like in the bath tube. He finally realized that when the water level goes up when he goes into the when he jumps into the bath tube, and that is, he realized the volume of his body, or generally the object submerged into the water, is exactly the same volume of the water displaced by such object. So now he can measure the volume of the object in the water, and he can weight the object. So he find a small piece. He find pieces of the real gold, and he put the gold into the water, and he measures the volume of the water displaced by the real gold, and he weighs the real gold, and he also did the same thing to the crown, and he found that the crown is actually having more volume than the real gold. So the crown is fake. Another observation from Archimedes is that he feels the upward force when he lay in the water. That is a buoyancy force. So he also realized the buoyancy force he received, or the object in the water receives, is actually equal to the weight of the water displaced by the object. That's very important. So now we know how to calculate the buoyancy force of a fluid or liquid, any liquid applied to the object. That is, when you know the density of the fluid, like the density is a mass over the volume, but we only want to know the weight, the gravity. So the gravity force is given by the m, the mass times the gravity acceleration, mg. But you only have the density. Density is mass over the volume, right? But once you know the volume of the water displaced by the object, now you know mass, and you know density. Density is mass over the volume, and you know the volume, and you have the gravity acceleration. So that's density times the value times the gravity. Then you got the, what's it called? The buoyancy force. So for larger object, that beach ball has a larger volume when you're trying to push it fully into the water. But comparing to this small ball, it has a smaller volume. So it's very easy to push the small object into the water. But it's very hard for larger things like beach ball. Thank you for watching.